Good day everyone. In our group video, we will be discussing the terms used in TRIM.
Initial stability. Initial stability is the stability of the vessel in her initial position and is expressed by the metacentric height. Any reduction in GE means a loss in the ship's stability. Statistical stability, it is defined as the stability of a ship to regain its upright equilibrium position after the removal of external factor which cause the vessel to heel at an angle. It gives the stability information of a vessel under the condition that the outside water is static. It is expressed in terms of metacentric height Jm for angle of heel up to 10 degrees and righting lever Gz for angle of heel above 10 degrees. Its unit is meter. Static stability at two different angles can be same. Statistical stability curves. When a ship is inclined through all angles of heel and the righting arm for each angle is measured, the statical stability curve is produced. This curve is a snapshot of the ship's stability at that particular loading condition. The curve of statical stability or GC curve, as it is the most commonly referred to, is a graphical representation of the ship's transverse statical stability. Dynamic stability. It is defined as the energy required in heeling the ship from upright equilibrium till the angle of heel in question. It gives the stability information of a vessel considering dynamic behavior of the sea. It is expressed in terms of area under righting moment curve or GZ curve. Its unit is meter radians. Next, transverse stability. The transverse stability is the ability of the vessel to return to vertical when she has been held. The heeling could be because of an internal force including the action of the sea and swell. It is always necessary to maintain stability even when a vessel has altered distribution of weights within the ship.
Longitudinal stability. It is the tendency of the vessel to return to its original plane after being inclined by an outside force. Any ship cannot rest in calm water. The center of buoyancy and the center of gravity will be in a vertical line. So, in this picture, we have the LCG and the LCB. LCB is the longitudinal center of buoyancy. This is the longitudinal center of the underwater volume and is the point to which all the buoyancy can be said to act vertically upward. And the LCG is the longitudinal center of gravity. This is the point to which all the weight of the vessel can be said to act vertically downwards. So the LCB is the upward and the LCG acts vertically downward. So in this picture, this is the vessel swims by the stern. And when the LCG and LCB are in the same vertical line, the rotation will stop and the vessel will be skimmed by the stern. So if the LCG and the LCB are in the same vertical line, then there is no swimming moment that will happen in the ship. And if the vessel had started with LCB act of LCG as shown in this picture, then the rotation would be caused a swing in the bow. So here is the bow. LCB act of LCG, vessel swims by the head. Damage stability. It refers to the stability condition of the vessel after collision on after grounding. It is the study of the stability of the surface ship comes out used and the ship's watertight hull is affected in a way that allows water to flood any compartment within the ship's hull. Since this changes the stability parameters of the ship, the extent of which depends on the extent of damage and flooding. So we have the effects of flooding on a ship. Change of draft. It is the flooding results in entry of water into the ship's damaged compartment. So the cause of this is a change in draft to the point where the displacement of the undamaged part of the ship will be equal to the displacement before damage less the rate of the water that entered the ship after flooding. Next, we have change of stream. If the increase of water in a compartment can be considered as an addition of the weight to any point along the length of the ship. So this causes a change of the trim of the ship. Next, the heeling. The ship will heal if the damaged compartment is unsymmetrically positioned above the center line of the ship. So if the metacentric height of the ship in the flood condition is negative, the damaged ship is rendered unstable, and in such case, the ship will capsize if the flooded compartment is unsymmetrical about the center line and is prone to capsize by action of any external heeling moment if the compartment is symmetrical about the center line. Next is the change in stability. So the metacentric height of the ship changes due to flooding and change in freeboard. The increase in draft of the flooded ship and reduction in freeboard, which poses a great threat to the residual buoyancy of the ship. So even though the metacentric height may be positive after flooding, the reduction in freeboard to a point which deck is immersed then decreases the ship's range of stability. So this means that the ship could not capsize due to external forces of winds or waves. Next is the force. Force is traditionally defined as any push or pull on the body. So whenever there is an interaction between two objects, there is a force upon each of the objects. And when the interaction ceases, the two objects no longer experience the force, because force only exists as a result of an interaction. Next is the resultant force. It is the force representing the combined effect of two or more forces acting as one. So it's the combined forces, and the resultant force, which is the R, is given by R equals F1 plus F2, which means that it's two combined forces, which is the F1 and the F2. Next, we have the couple. The coupled forces is formed by the two equal forces acting on a body in opposite directions and along parallel lines. So all couples are expressed as a moment, and it's not produce any translation and only rotation. The resultant force of a couple is zero, but the resultant of a couple is not zero, it is a pure moment. So example, when we use a steering wheel, when we use both hands, then the two hands are coupled but moving on a different position or in the opposite side. So when they apply a force that is equal in the magnitude yet opposite in the direction, then the wheel rotates. And if both hands apply the force in the same direction, the sum of moments created by each force would equal zero and the wheel would not rotate. Moment of a force. It is a measure of the turning effect of the force about a point. It is the product of the force multiplied by the perpendicular distance from the line of action of the force to the pivot at point where the object will stand. So the formula of the moment of force is moment of force Newton meters equals force newtons times perpendicular distance. So the force to the pivot in meters.
Resultant moment. When two or more forces are acting upon a point, their combined effect can be represented by one imaginary moment called the resultant moment. The process of finding the resultant moment is referred to as resolution of the component moments. Heel. A heel is a temporary inclination of a ship caused by outside forces such as wind, waves, or during a ship's turn. Whenever the center line of the gravity of a ship is moved off center line, the ship will create an inclining moment if no external forces are present. The ship will assume a list. Listing. Listing is a nautical term to describe when a vessel takes on water and tilts to one side. A ship can list either to port or starboard. By contrast, a ship is said to be trimming when she dips forward or backward. The angle of list is the degree to which a vessel heels to either port or starboard at equilibrium. With no external forces acting upon it, listing is caused by the off-center line distribution of weight aboard due to uneven loading or to flooding. Mass. Mass is a measurement of quantity of matter contained in an object. It is property of matter and does not change. Weight. Weight. Weight is a measurement of the effect of gravity or other acceleration upon an object. The same mass can have a different weight depending on the acceleration. The specific gravity, SG, or relative density of a substance is defined as the ratio of the weight of the substance to the weight of an equal volume of fresh water. If a volume of 1 cubic meter is considered, then the SG or relative density of a substance is the ratio of the density of the substance to the density of fresh water.
So my name is Jonathan Ambo, a Group 2 reporter about the terminologies too. So definition for terms, we have density, trim, change of trim, longitudinal center of flotation or LCF, and last is longitudinal center of gravity or LCG. So we have first the density. Density is defined as mass per unit volume. The formula for density is D is equals to M over V, where D is the density, M is for mass, and V is for volume. Next is trim. Trim is defined as the difference between the forward and aft draft. The trim of the ship describes its flotation position in length direction, namely the bow and the aft of the ship is deeper submerged into the water. The trim can have a significant impact on the vessel's energy demand for propulsion during sailings. Next, change of trim is defined as the difference between the initial and final trim. So change of trim increase of water in a compartment can be considered as an addition of weight to any point along the length of the ship. This causes a change in the trim of the ship. Next, longitudinal center of flotation or LCF is the point about which the vessel trims. It is the center of gravity of the waterplane area, also called as the tipping center. So geometric center of the ship's waterplane. So this is the LCF or the longitudinal center of flotation. Next, longitudinal center of gravity or LCG is the longitudinal distance of the subcenter of buoyancy from amidship, sometimes measured from AP or FP. So LCG, the longitudinal position of the center of buoyancy with respect to any reference point of the ship, is called the longitudinal center of gravity. So that's all. Thanks.
So good day everyone, so I'm Balen Jumarga Kushan and I'm here to present to you the said topics. So the contents of my topic, which will be, number 1 is the longitudinal center of buoyancy. Number 2 will be the longitudinal metacenter. Number 3 will be the trim arm. Number 4 will be the trimming moment. And number 5 is the parallel sinkage. So let's start with the longitudinal center of buoyancy. So longitudinal center of buoyancy is the longitudinal distance of center buoyancy from amidship, sometimes measured from AP to FP. A longitudinal position of a center of buoyancy with respects to any reference point on the ship is called the longitudinal center of gravity. Usually the referred point of locating the LGC is either of the forward or the aft perpendiculars. So number 2, which will be the longitudinal metacenter. Longitudinal metacenter is formed by the intersection of lines forced through the B. Before and after small longitudinal inclination, the point of the vertical line through the center of gravity of a ship whereas the line is intersected by a second vertical line through the center of buoyancy when the ship is inclined at a very small angle in the fore and aft direction. So number 3 will be the trim arm. So the trim arm is the distance from the even keel or LCB to the LCG. As the vessel trims, the LCB moves this distance to a position under the LGC. Number 4, the trimming moment. Trimming moment displacement x to LGC minus LCB. When the LCG is forward to LCB, then the vessel trims by FWD. And when the LCG is aft of the LCB, then the vessel trims by the aft. Once we have the trimming moment, the next step is to look at the hydrostatic parameters called the moment of change. Trim by 1 cm MCT cm. So trimming moment is product of letter A, delta x trim arm to LCG method of trim calculations when large chains of draft occur. Letter B is WXD used when loading, discharging, or shifting small weights. So these are the said formulas. The parallel sinkage, which is the fifth and the last. Parallel sinkage is the act of the vessel changing its draft, so the forward and after draft are changed by an equal amount. The result is change in draft without any change in trim. Calculate the parallel sinkage using TPI pertinent to the new water. Parallel rise sinkage PR or PS when the weight is removed, added from to a ship at LCF, the forward and aft draft will change by the same amount. So thank you for listening to my report. I hope you have something graduate information. So go to the next reporter.
Good afternoon. I am Rayan Isanyo and I am here to elaborate to you what is TPI, TPC, ITM, MTC or MCTC, mean forward and aft draft, and mean midship draft. TPI, or an imperial tons per immersions, commonly abbreviated to TPI, is the number of imperial long tons to 2,240 pounds that is needed to be loaded on a vessel for the draft to increase by 1 inch. Old imperial TPI measurements are still occasionally used within the US and the Panama Canal. TPC, or tons per centimeter. For any draft, it is the mass which must be loaded or discharged to change a ship's mean draft in a salt water by 1 centimeter. The TPC is displacement. The TPC varies with the drought and with the water density. Changes in drought cause a change of displacement, and the TPC assists in calculating the change. Next is ITM, or International Tanker Management, is a ship management company with a special in oil and chemical tankers. ITM provides tankers owners with comprehensive ship management package covering technical management, new building supervisions projects, services and insurance, and claims handling. All services are offered within a cost competitive and quality environment. Next is MTC or MCTC, or commonly known as moment to change term by 1 centimeter. Is the geometric center of the underwater volume of the ship, that entire buoyancy provided by the displacement of water may be considered to act vertically upward through this point forward. Next is mean forward and aft draft. The average, it is the average forward draft and aft draft. Next is mean midship draft. It is means the average of the port and starboard side draft of a midship.